Hello, everyone. Happy to have you all here for this call with the Hedera developer community. I am Ed Marcus, and I work in the developer relations team at Soros Labs. And today, I have an amazing group of speakers with me. We also have a team again from Validation Cloud for an announcement regarding infrastructure for devs. And I'm also here with Nana, Michael, Patches, Ali, Keith, Mika, or DeFi Girl, and myself. So we're going to be your presenters for the day. So let me share some logistics with you first. This call is being recorded, and it will also be posted in our channels afterwards. So please make sure you mute your mic while others are speaking, just to avoid any background noise. And also feel free to share this recording with other people who couldn't join us live. Maybe they can benefit from watching this recording and hearing about some of these updates. We also are planning a Q&A towards the end of the session, but we also have a chat for the stage, so we'll be keeping an eye on that. Make sure you share your questions there. And then we'll also be taking some questions in between segments and transitions, so feel free to share those questions via the chat. And finally, we would love to hear your thoughts, your feedback regarding things that we can do better with, things that we could improve for developers. So make sure you share those thoughts via these brief survey. I'm going to leave the QR code here for a few seconds, so you can take it on your phone, maybe get a screenshot of that, and then go to the survey. But we're also going to send a link via the chat just for convenience. And interestingly, there's a question there towards the end about being part of focus groups, just to help us drive improvements, answer some of the key questions and lead conversations. So if you're interested in being part of that, make sure you share your contact information with us to help us drive some improvements there. So that is the housekeeping items. Now let's jump into the agenda for today. The goal for this session is that you'll hear from the community and also from experts at Soros Labs about recent network developments. So we're going to start with some announcements. I'm going to start covering some high-level use cases, hopefully for inspirations for those of you who are developers, so you can see what others are building, other relevant changes as well, and where you can find information. Then we're going to have an announcement for Validation Cloud about infrastructure for devs. Really excited about that. And then we're going to hear some updates from the Soros Labs team, specifically some updates regarding the security changes to the Smart Contract Service. That's going to be presented by Nana, who is one of our engineering managers. Then Michael, one of our developer advocates, is going to cover the Hedera Improvement Proposals, or HIP, and more specifically, what are some of the criteria that we look at for prioritizing features or changes that may be requested by the community via that process. So I think that's going to be a very interesting topic as well. And then in the third leg of the presentation, we're going to jump into topics that the community provided feedback on and voted on. So the first topic there is going to be about HIP 657, and this is about dynamic NFTs, enabling those, and that's driven by this change of mutable metadata now being available in Hedera tokens. So Patches is going to cover that from the community. Very excited to hear what he has to share there. And then we'll close with a quick update on decentralization efforts, which will be covered by Ali and Keith, both who are part of the product team at Soros Labs. So with that in mind, I'm going to start with the high-level announcements about use cases, hopefully, so you can see what other developers, teams, and enterprises are building there for inspiration. So the first use case here is Galaxy. So this is pretty fresh. They launched their application in the past few days, and Galaxy is a next-generation social media network. So I encourage you to check that out, read this article, and you can find more information here at the blog from the HBAR Foundation. Last week, if you didn't hear, or a couple weeks ago, there has been an integration as well with the Fresh Supply Co. and in the backend as well with MasterCard network. So another exciting update on how Hedera keeps driving real-world value and how developers are enabling that. This one was one of my favorites, having a little bit of an automotive background. So Hyundai and Kia basically building a system for monitoring CO2 emissions on the Hedera network. And then also a pilot that was completed for stablecoins between two international banks to improve international remittances, all built on Hedera. And then finally, the big news that we all started hearing about this week is how Drop is basically part of service providers for the FedNow system. And Brandon, the HBAR Bull, has an amazing video with Drop's CEO about what that team is doing. So I definitely encourage you to look into those use cases so you can see how Hedera is being used and applied in different areas, driving utility. And then on the other hand, we also have the Hedera blog where you can hear about some of the latest updates and also use cases that may be happening. But the one that I want to mention here in reference is a change to the staking program. So I encourage you to check out this blog to get all the specifics. But that was a change that happened, I believe, a couple of weekends ago. So if you're not familiar with that, make sure you check out the Hedera blog to see the latest updates that are part of the ecosystem. So hopefully that shares a little bit of inspiration, a little bit of updates regarding changes and where you can find more information. If you're a developer or maybe an end user excited about the ecosystem, I think these are resources that are great to know about. And so I'll hand it off to Nana regarding the updates to the security model of the smart contract service.
All right. Can you guys hear me okay?
Yes, sir. You sound great.
Okay, perfect. Let me share my screen. Let me know when you see the slides.
It's coming through.
Okay, great. Good morning, good afternoon, and good evening, everybody, wherever you are across the world. Really excited to talk to you today at the technical community call, and I'll be sharing about Hedera Smart Contract Service security model update. Actually, okay, great. My name is Nana Sofikondia. As Ed mentioned, I'm an engineering manager at Swirls Labs. I'm focused on the smart contracts team, so I lead most of the efforts there. I've been at Swirls Labs for the entirety of the company's existence, but joined Hedera late 2019, so about 3.5 years on the team. In terms of socials, if you want to reach out to me, these are my handles. Feel free to connect with me. My team is hiring. I'm especially looking for a staff engineer with really in-depth EVM knowledge and tooling as well as Java services. So interested there. If I'm to summarize my role, it's really to help sort of create and manage open source software across the different Hedera branches, but really focused on enabling all Hedera DLT flows. My background, about 15 years in the industry across different places like aerospace, biotech. I was at Microsoft for a bit doing enterprise device management and did some consulting as well. If I summarize my goal as well as my teams, it's really EVM equivalence using smart contract service. So the goal there is just making it really easy for anybody coming from any EVM chain. So that's Ethereum, whether it's Polygon, really just, change your RPC URL, point to Hedera, and you should be off to the races. And so my team is focused on figuring out any issues around that and resolving them. Some ideas that are top of mind for me at this current moment are a few things I wanted to share as well. So diversity is something that's really important to me, making sure you have really good representation in the rooms of decision-making and conversations, across different cultures and ideas as well. Thoughtfulness is also something that's important to me. And when we do that across development, to me, that includes things like making sure you put on the customer hat or you engage with community members like yourself and really understand what the use cases for people are, as well as, hopefully using some data to back up some of the decisions that you do as well. And then the last one would be systems thinking. None of these things are done in silos. So it's not always easy to change one thing without making sure you fully understand how it affects the overall ecosystem. And so my team and I are really thoughtful when it comes to that part. So I figured I would give a quick smart contract execution primer just to set the stage and make sure we're all on the same path. And I'm sure that most people are comfortable with the idea of you start with some code, whether it's in Solidity, Viper, you compile it, you get some EVM bytecode, and you deploy it to a network of your choice, hopefully Hedera, and then you get some contract. And at some stage, you're going to interact with it. But what's really happening on Hedera and, maybe why are some things so complex or not easy to change? So at some point, you're going to start off with a wallet, whether that's your favorite Hashpack, Blade, or MetaMask wallet, or maybe you're using a tool like Ethers or Web3 that has wallet capability. You're submitting some kind of a smart contract to the ledger, and the smart contract service is going to handle that. Usually where it starts off is with this thing that we'll call a transaction handler. And that transaction handler is basically going to take in your inputs and decide, where do I route your call to? Let's say that it's a straight up, an ERC20 or 721 token interface that you're trying to do, and it goes to the EVM. The EVM itself has its logic that is going to, in a stack frame manner, decide what changes need to be made and how they apply, things like, do you have enough gas, etc. As part of that execution, it's going to make some queries to get a bit more information, usually around a smart contract or an account, or maybe the bytecode itself. And so you'll see these queries going off, but where it's really pulling that information from is the Hedera ledger itself. So the Hedera ledger contains these things that we'll call contract key values or key value pairs. And these are really just, within your smart contract, if you define the variable, there's a key value for it, and we'll be able to pick that up. It also stores all the bytecode for contracts. And so all these items are going to be sent back to the EVM to decide what to do. There's also this concept of precompiles, and I wanted to take this moment to quickly distinguish between precompiles and system contracts. So precompiles are essentially any functionality within a smart contract that can be compiled in advance and saved on the EVM. So the reason why you might do this is you're doing some kind of complex functionality, like creating the hash of something. So instead of having every person deploy a contract that will continue to do the KEKAC hash, for example, it over time has become realized that it's really cool to just compile that ahead of time, make it performant, and make it exist as if it was a smart contract that was already deployed and all smart contracts can call it. So those are the precompiles. And if you're looking on the EVM, I think there's actually only 6 right now, and that number is probably going to increase with the next sort of Ethereum hard forks. But that's different than system contract executions. When you think of a system contract, it has a similar mentality in that there's some address that's reserved as if it was a smart contract, but it's not really. And when contracts call that, they're able to access some functionality. But in this case, it's not pre-compiled bytecode. It's actually live dynamic Java code. So when you call a system contract, what you're actually doing is you're tapping into the Hedera API services. And so in this case, many of you will be aware of the HPS system contract functionalities. So when you call a system contract, what you're really doing is tapping into the Hedera token service Java code and running that live. So there's that distinction. So in a similar manner, if you were to call some HTS, say token wiping or minting logic, that transaction handler is going to go off and sort of execute this logic. And you'll see this dotted line over here. And the reason why it's dotted is because post the new security model, this actually isn't here. But as part of that, you would have queried and directly updated the ledger storage as well. Other flows, of course, it just exists from the transaction handler being able to go off and query and update the ledger storage as well. So one thing I want you guys to take away from this is you'll see there's lots of different assets, there's lots of different boundaries that are important, and you can already get a sense of the complexity that's going on here. So coming to the sort of the core of the topic, the security model. I looked around a bit to find some definitions and see what was good, and I kind of did an amalgamation of things that made sense to me. So security model is really just a framework to help you define and maintain, I'd say, security policies around key assets and boundaries within a system. So from a previous diagram, you'll think of some of those assets as smart contracts, you'll think of them as the accounts, you'll think of them as tokens, and all those informations that are important, but also the boundary of being able to decide who can access it and who can modify it. In this diagram or this sort of image over here, you'll see that a couple of people use security models to reduce many things, but also enable others. So it helps you, of course, reduce security risk, but it also helps to give you like a framework or mindset to respond to certain issues. It also gives you a good idea of how you might deploy certain technology. And in some cases, it even helps you to be a bit more performant. But when we apply that to Hedera, the way I kind of see it is the security model really helps us to protect the network, right? It also helps us to protect users, which is really important to us. These two things are very core to us. Before we add any new functionality, we'll never sort of give up the protection of the network or the users. We also want to, of course, increase the clarity of feature functionality, but also enable developers to really understand what capabilities look like, what should they do and what maybe should they not do. And hopefully as part of all of this, we reduce the complexity of the system as well. So where these things are really important and the need for the new security model, I wanted to highlight two different scenarios that came up pre the new security model that were important. And to do this, I'll highlight two different call flows. So many of you will be aware that, like I shared before, you have an EOA from your wallet. You're going to call some kind of a contract. Let's take this scenario here where you have an EOA that calls contract A, which then calls contract B. Contract A has its code and it has its state. Contract B also has its code and its state. And there are these useful sort of parameters on each of these contracts to help give us a bit more insight. And so we have this concept of an originator. This is the person that submitted the initial transaction to the network. Then there's the concept of the sender, the person that sort of submitted this call frame, as it were. There's the recipient of the call, and then there's also the value in terms of cryptocurrency that's being sent, and then there's the address of the contract being executed. So you'll see that when EOA from their wallet, like I said, MetaMask or Hashback, Blade, etc., makes that call to contract A, the originator is the EOA, the sender is the EOA, the recipient is the contract A, the value will be any HBARs that were sent across, and the address is that contract A that you called. Now let's say contract A then calls contract B. You'll see that the originator stays the same. That makes sense. The EOA submitted the transaction. The sender is now contract A in this frame, and the recipient is now contract B. The value is going to be any HBARs that contract A decided to send to contract B, and that has nothing to do with the EOA itself. And the contract address, of course, will be contract B. So with this frame sort of set, it's really important to understand that before the new security model, we had this concept of top-level signatures that could be accessed by contracts. And so what this meant was that when EOA submitted any transaction and it signed it, those signatures could be accessed by any and all of the contracts within the stack frame. And so that meant that if EOA signed off on, say, an operation to do, the transfer of token A, if contract A or contract B wanted to, it could also use that same signature to give authorization for, say, transferring another token or extracting some other information or even associating with other tokens. So basically, if an EOA signed off with their admin key, these contracts could do any transactions at all. And whilst that might enable UX for adapt or other scenarios, it's also very tricky if the EOA doesn't understand what they're signing up for. And this was actually really called out very well in HIP 286, where we advised that, be careful how you use your admin signatures, because if you sign off on one thing, you're essentially signing off on multiple things. So it's very important to know what you're signing off on. And so you guys can probably already see how some of this might be both useful, again, on the UX side, but problematic to EOAs or users that don't understand what's going on, or malicious contracts that might decide to do anything that a user is not ready for. The second flow would be that of the delegate call flow. So the delegate call flow looks similar to the call flow, the exception, of course, being that one contract or one caller delegates to another. So in this case, let's say that contract A delegates to contract B. What delegation really means is that I'm giving you the authorization to run your flow, but run it in my context. So what that really looks like is when contract A delegates to contract B, it's saying, hey, run your code, but run it in my context. So you'll see that if we look at the properties here, the originator, of course, we would expect that to be EOA. But what's interesting here is that the sender remains the EOA. The recipient also remains contract A. And the value of the HBARs being sent is also that coming from the EOA. The only thing that differed is the contract code address in this case. So really what this looks like is it looks like contract B was called by EOA and that there was no sort of call over here. So contract B's code runs as if it was in contract A's state. Again, another thing that enables UX and is really important, but it can be illicitly used and actually was in March, right? So you can read up on the blog there, but what happened was somebody malicious was able to swap out contract B for something else that the EOA wasn't aware of and run their code in the context of contract A, which probably had permissions to do so. Again, this was another thing that we explicitly called out in HIP 206, but it's still really important to get this right. So both these scenarios really show why it's important to understand how contract flows work, but also understand the security implications of signatures and allowing that out. So those two things together really made the team come together and really sort of re-architect the approach that we were using. And when I say we came together, I really mean we came together. It was literally a week, tons of meetings from like 8 a.m., whichever time you were, all until sort of the evening until people had to go back to their families. So we took this really seriously, and I want that to be clear to people on the call and who might watch this later on, that the engineers across and the product as well, we really took this seriously to really identify different problems, empathize with users, both EOAs, DApp developers, define the problems, or really ideate around understanding what people are trying to achieve, but also understand from a user's point of view what misconceptions there may be, and then also from a malicious side, what could somebody do if you didn't understand? And that was really the goal around the new security model and the definitions there. So after taking quite a while to really dig in there, we came out with a suggestion. Again, you'll see this in the blog post and on the docs site for smart contracts. But if I'm to summarize it, really what we did was we took away the capability for smart contracts to use top-level signatures. We also prevented delegate call to system contract calls. And then we suggested this sort of three-level approach. So the three-level approach is really just, the first one is think about it from the EVM first and foremost. If there's anything that the EVM can do and cannot do, then you should expect that to be the same for Hedera's security model for smart contracts. And where this is really important is from the EVM standpoint, entities can only modify their own state and their balance. And if anybody else tries to do that for an entity, it won't work. And so we start there. And that's really safe and secures and ensures sovereignty of accounts as well. The next step is we basically take any tried and true ERC models. Currently, those are the ERC20 for fungible and ERC721 for non-fungible, and we adopt some of the functionality that they've provided. And so for those, that would be the ability to provide allowances and transfer from. And so those are things that we support as well. And the third stage would be basically any Hedera advanced features around authorization. And so one really important one to call out would be the ability to set contract IDs as keys. And so some of you may be aware, but just a quick highlight for those that aren't, you can sign transactions with signatures, but you can also specify that for a certain operation, instead of looking for a signature, look for a contract ID. And so this might mean that for your HTS token, maybe you set the KYC key as a contract ID, as contract A. So that means that if contract A calls to try and do a KYC, it will be allowed. If anybody else calls, signs with any other signature, it won't be allowed. And so this really allows for different decentralized operations in which you can give permissions to a contract to carry this out. This might be really important for DAOs and other scenarios. But this mindset and this frame is really what we're saying and suggesting developers to look at going forward in terms of the security model. So let me sort of make that a bit more explicit in highlighting maybe what EOAs can no longer do and what contracts can no longer do. EOAs can no longer use deployed contracts to approve allowances because that would break the sovereignty model. It would basically mean that you're saying a contract somewhere else can change my properties. You have to change your properties on your own. In the same sense, EOAs can no longer use deployed contracts to associate tokens. You should associate tokens yourself. Also, in summary, contracts can, like I said, you can't delegate call to a system contract function. You also cannot, as a contract, transfer funds for other people or other entities without their allowances ahead of time. So if an EOA or a contract gives another contract an allowance ahead of time, then that contract can carry it out, but otherwise it cannot. And the rest is just really saying that, again, entities and other properties cannot be changed even by using top-level signatures and other items there. One scenario to call out is the ability during a token create to establish a treasury or an auto renew account that is not the contract. This was, in a sense, removed with that change for the safety reasons that we mentioned here. And so sort of just to close off here, general advice, treat all entities as as if they're sovereign because they are, and that really ties in well with the sort of the paradigm of DLT. So an account should always be aware of its changes and should carry it out itself. The same thing with a contract. However, you can provide in advance approvals when it comes to things like token transfers or balance transfers in general. Utilize contract IDs on Hedera as appropriate, where it makes sense for things like burn, wipe, freeze key, etc. But in general, practice sign-in vigilance and contract hygiene. Really understand as an EOA what it is that you're signing and what you're signing up for. And where possible, as developers, try and utilize standard approaches across the ERC or HRC interfaces. For some of you, this might be the first time to see the HRC concept. And so just as Ethereum has Ethereum request for calls that are related to their EIPs, we have the concept of Hedera request for calls that are related to HIPs. And so you'll see that in HIP 376, we presented ERC20 and 721 methods. These are standard. And so similar in HRC 719, we provided a standard where EOAs can associate tokens directly without having to call a smart contract. And so finally, just to sort of highlight some things that are coming soon, I mentioned that gap around token create and a contract being able to assign an auto renew or a treasury account. And so in HIP 756, there's a suggestion as to how we'd be able to achieve that. So I'd encourage you all to read HIP 756, and it also relies on HIP 755. If you have any feedback or ideas there, please go ahead and sort of like comment on that or share with the team. But this, we believe, should unblock that functionality. And then also we're hoping and working on smart contract verification, as you would have probably experienced on other chains, to make this really easy for people to be able to go to different explorers and see that a smart contract had been verified and see what code is actually running. So that's it for me. I'm happy to answer any questions. I don't know, Ed, if we would do that now or later, but whatever works for people.
Thank you so much, Nana, for this well-structured and clear presentation on the topic. I thought this was a great overview. Maybe I'll call out a comment from Cantor Codes from NFTs. I believe you covered this in the presentation, but he made the statement, so effectively for token allowances, the security model is now very well aligned or the same as the EVM. Is that something that you can add some additional thoughts on or confirm?
Yes. Astute conclusion, yes. So what we really wanted to do, this was very intentional. Why create a new security model if there's one that helps us and has been tried for years, right? So yeah, there are a couple of ERC security models that we wanted to incorporate. 20 and 721 is that. So it's intentionally aligned with that so that you can utilize the same sort of contracts that you might have used across other chains on Hedera as well. And in the future, if there are, again, ERCs that, again, have stood the time and have been, tested and make sense, we might incorporate those as well. But yeah, it's very intentional that we wanted to have that alignment as it benefits the ability to sort of move tokens across different chains as well. Yeah.
Excellent. And there's another really good question. Let's ask this one and then move on to the next topic. But this one is from Hedera Dev. So how do we know what we signed for with a smart contract if we cannot see the source code of the smart contract? For instance, with Etherscan, you can look this up.
Yep. Great question. And so that's what I'm saying is coming soon. So the team is working on the idea of smart contract verification, and rightly so, as you said, similar to what you would see on Etherscan, whereby when you go to Hashscan and you look at a contract, you would be able to see the smart contract code behind that contract to verify itself. I also think this would be an interesting place for wallets to sort of provide functionality that hasn't been seen on other wallets in advance, where they could probably tie those things in together. This is me personally speaking, of course, not on behalf of the company, but I think it would be really cool to be able to, ahead of signing for something, be able to see within my wallet what's going on and what could potentially happen. But we believe that the smart contract verification on the Explorer will provide that functionality that you're used to on Etherscan as well.
Excellent, Nana. Again, thank you so much. I think we'll hold it there with questions and then maybe revisit at the end if there are any additional ones. So at this time, let's bring Michael from the developer advocate team to talk about the Hedera improvement proposals.
Thank you, Nana, for that. That was great insights on the new security model update. If you guys haven't had a chance to look at that, I strongly recommend you do it and possibly rewatch this because there was a lot of information in that, a lot of very important information. A lot of resources went into that, careful consideration and time. So I just wanted to touch on that before I get into what I'm talking about. So yeah. Nice to be on the call with you guys. We have a great community. I love talking to you guys, whether it's about Hedera or other stuff. But yeah, I just love the community that we have. Today, on this call, I'm going to speak to prioritization of HIPs and new features. But first, I'll introduce myself. If you don't know me, my name is Michael Garber. I'm a developer advocate at Swirls Labs, which I have several roles on the product team under the developer advocates, where I look at the manage the HIPs repo, which we'll talk about that, the repository for HIPs, which is Hedera Improvement Proposals. And then I also act as like tech support and a liaison between projects who are building on us and some of the questions that they have, maybe technically. A little bit about my background is I've been in blockchain, been interested in blockchain since 2011 and really got hooked around 2013. And I've had some experience working at a blockchain consulting company, and I've done some contractor work at MasterCard, and now I'm here. So that is a little bit about me. I also created a site called Forum, which is a free speech website, immutable free speech website built on the Hedera consensus service. So that's a little bit about me and my background. So let's talk about HIPs. All right. So what are HIPs? It's an acronym for Hedera Improvement Proposals, and what they are, in essence, are formalized suggestions brought forth by the community or by council members, or really by anybody who wants to suggest an improvement for Hedera, ranging anywhere from protocol changes to applications built on Hedera using Hedera. And that is what they are. They're very similar to EIPs, which are Ethereum Improvement Proposals, but we're Hedera Improvement Proposals, hence the acronym HIPs. If you want to find out more about that in the process, I've put here a YouTube video that I've recorded about a year ago that outlines the whole process of HIPs and their life cycle, and gives you examples of the different types of HIPs that we have. Yeah, I'll put this in the chat, actually. I don't want to go too far. I'll put it in the chat after I'm done with this. But there's a good YouTube video. I know it's good because I recorded it so for you all. No, I'm just kidding. But it outlines the HIP life cycle, the different types of HIPs that we have, and that sort of thing. It's hopefully informative for you all, and you get some value out of watching that. The HIPs, they live on GitHub, and GitHub is a site where you put a bunch of code. So where the proposals happen is on GitHub. That's where they live forever. So when you propose them, they get merged there, and that's where they stay. Things that you can do to prioritize HIPs. You can either propose new HIPs if you think about an idea to improve the network, and this really extends to anyone, not just developers, but really we want to harp on the point that anyone can do this, not just developers. You can propose ideas for new HIPs and discuss them there. And just really kind of anything. If you're using Hedera and you find a way that, or you think of a way that might make whatever you're trying to do better. I'm trying to think of a good example. We have some examples like 583. It might be a little too technical, but it brought us to parity with up to parity with Ethereum as far as Ethereum equivalents, EVM equivalents, and so that has allowed us to be able to use MetaMask. I'm trying to think of a less technical example for you guys. There was one that the community got together and formed a standard around how NFT metadata should look. So I know Patches was involved in that, May-chan, shout out to you guys, Ash. I mean, all you guys, great community members, came together, and that was a really great HIP that demonstrated the community coming together in a decentralized way to improve the network. So I wanted to highlight that as an example of a HIP. Yeah, thanks, Ed, for letting me know about the time. So if we're talking about one of the topics that was brought up for this call is the prioritization of HIPs. The community was voted on this subject. You guys wanted to hear how do we better prioritize HIPs, and so I thought I'd walk you through a few of these different ways to do it, and explain what HIPs are and how they come to be, and basically who yeah. So so discussing the ideas on the HIP itself on GitHub is hugely important. That is where the ideas are formed that create the HIP. So it is highly, highly encouraged that you all make, if you don't have a GitHub account, just create one and start commenting, start engaging there. That is probably some of the biggest stuff that you guys can do as community members and engaging with the HIP process to help move them along. So to talk about HIPs, really it makes a lot of sense to also talk about how we compare to different networks. So the way we have, at least as far as the decentralization process goes, and Ali will speak to more of that, in the beginning, in our path to decentralization, it's in a way where we have permission nodes, which are owned by council and our governing council, like with the biggest names in tech, like Google and LG, Standard Bank, different industries and verticals all over the world in 8 different continents are running nodes. We start there. So they have the network, they make the decisions on the network, and as we expand out further into and decentralize more, which Ali will speak to more, stuff will obviously processes will change then, but the way they are now, engineering prioritizes work based on the recommendations of council is probably the biggest thing there. Another thing that's looked at are things like impact to network. How many transactions will this HIP bring to the network? What sort of effects do they have on stability or performance? Another thing that is hugely important is the resource availability. Nana just spoke about the security model update. We spent a lot of resources and careful consideration on that, and it took very high priority because of that to protect users. And so resource availability is definitely high on the list for prioritization. I mentioned on the last slide that you all can propose the HIPs, and you can also contribute to the conversations on GitHub. And whether it's on GitHub or on social media, it's important to outline or talk about the dApps that will be using these HIPs, or the different use cases, potential users that would come to the network. All of these things have a factor in how HIPs and the work related to HIPs are prioritized. And of course, always engage on social media channels. We saw with Patch's HIP, the mutable metadata, when the community really rallied behind and started talking about the mutable metadata, the priority bumped a little. So definitely engaging on social media is hugely important. So by doing that, you make your voice heard. And like I said, be sure to mention the impact. If there's a big impact, of course, it's a high priority. If there's a big impact on the network, high priority in the list of work items that we execute. And in the process of doing all that and engaging and contributing your ideas, we not only do we further decentralize our efforts, but we also build transparency in the process, which is a crux of decentralization. So that's it. Do you guys have questions?
I don't see any questions coming in through the chat at the moment. But again, we'll stay tuned for any questions that may come up towards the end. So thank you so much, Michael, for this great overview. Patches, I believe you're ready to go as usual. So I'm going to go ahead and stop my screen share and let's go with your topic next, which is around HIP 657 regarding mutable metadata and dynamic NFTs. Patches, all you.
Fantastic. Awesome. Yeah, and just want to thank you guys for having me. This is really cool that you guys do these community things in Discord where a lot of us live most of the time. And yeah, excited to be talking about HIP 657, which, as Michael pointed out, if you're on Twitter, you've seen the memes. The community is really excited about this mutable metadata, and I'm just going to go over, why exactly and what this means from my perspective, and I think a lot of the community's perspective of the innovation that this specific HIP is going to bring to the Hedera ecosystem in both the NFT ecosystem as it exists today, and I think enterprise ecosystems and usability throughout kind of any use case you can think of. So mutable metadata, bridging the gap between static and dynamic NFTs. Who is Patches? I is Patches. So just a brief background on me. I am a co-founder of a company called Hgraph. We are a Web3 and AI consulting firm, typically working with enterprises, and we also run a mirror node through GraphQL, bringing some pretty cool data and understanding of the Hedera network through that node. I'm also a CEO of Turtlemane, which has created NFT services and music platform. Today we're actually launching It's Brandon's and D&D music on Turtlemane at 7 p.m. Eastern, which has 15 plus files in the metadata that Michael was talking about, where you can have multi-files, so it makes music really cool. So very, very much appreciate May and all the community that came together to make HIP 412. CEO of Hgraph Punks and Moonshells. Those are NFT projects in the ecosystem we've been building since September 2021, doing a lot of cool new things, always trying to be innovative. Co-founder of The Liftoff, which is a digital metaverse venue. We partnered with Fasizi, and actually, which is another NFT project on Hedera. And 2 weeks ago, we had a Grammy-nominated artist playing a show from an LA soundstage, live streaming into The Liftoff it was token gated for Hgraph Punks and Fasizi holders. So trying to continually push what music can be in Web3 and creating digital experiences that are, from my perspective, on the cutting edge of how artists can engage this technology and make a living off of it, and people gaining value through NFT ownership and token-gated experiences. And then in general, just been building for about 2 years on Hedera, submitted HIP 657 and a couple other HIPs, and just continually, I believe in the technology, and I like working with the community to see how we can get this out to mass adoption so that people can start using decentralized and all the benefits that come with what Web3 is over centralized databases and everything in that day-to-day life. You can find me on Galaxy at Patches, which is an amazing application I've been obsessed with since it came out. And I'm also on Twitter or X or whatever the name of that is at TMCC Patches. So the NFT metadata challenge. There is no native way to update NFT metadata on Hedera. So currently, if you want an NFT to change the way it is viewed or the data on top of it, you would have to do a centralized solution, which would be like, hey, I have this server on Amazon. I'm going to put this image here in this metadata, and I'm going to put that into the metadata field. So in that way, you can change the image and the user would see it. But the problem is the longevity of that is very problematic. If that URL ever changes, then the user is just going to have a dead token with no image or content. And it's just not really to the true ethos of Web3 that uses things like IPFS or interplanetary file storage, which is a decentralized node network that shards images to make it very easy for people to see, and it's not in one server, so if that server goes down. It's a kind of a Web3 way of saving imagery, and that's not currently possible on Hedera to have something pointing to IPFS and to be able to update it. So dynamic interactions and NFTs remain underutilized in the Hedera ecosystem, while again, from my perspective, the entire network and underlying technology is best of class. And so if we get this dynamic interactions in NFTs on the best of class network with its throughput and its speed and its cost, I think just a world of opportunity explodes with creation and creativity that we can't really think of right now. It's once it's in the wild, it's going to be really cool to see what happens with it. So how does this work? The idea behind 657 is that we introduce a new key. When you create a token ID, there's a couple keys that you can put on it today. You can have an admin key, which allows you to change some of the default attributes of that token ID from the name and other things. You can put on a supply key, which allows you to mint subsequent NFTs onto that token ID. A wipe key, which allows you to wipe it out of any wallet if you want to destroy a serial number or something from someone's wallet. And so this would introduce a metadata key. And that would allow a creator to add a metadata key to a token ID and then do a transaction on the network that would update the field that actually holds the URL of what that metadata is. So a simpler way to say that is if you hold an NFT that the creator wants to update, they would just go to the network and fire a command using the metadata key, and then that NFT would update. And that's great. It would achieve a functional parity with other networks. So if you go to Ethereum, Cardano, like pretty much any other network that uses smart contracts instead of obviously the Hedera token service, the ability to update metadata is just kind of guaranteed. It's just a thing that people expect to be there. And with Hedera not having an ability to update the metadata of a NFT that's outside the wallet, it reduces a lot of functionality. And when people come over and start exploring Hedera, it's kind of a handicap that they're not expecting. So it would, with this HIP, we are going to achieve functional parity because this HIP has been approved by the governing council. We're just waiting for it to get into the network. So great times are coming ahead. And it would facilitate dynamic NFT creation so that we could have this new opportunity of new interaction methods with the NFTs that are created on the Hedera network. The potential of dynamic NFTs, I think, is immense. So there's a lot of different ways that a NFT that is immutable and yours updating can bring a lot of value to the user and a lot of communal aspects and just a more immersive experience with what an NFT can be. So right now it's pretty standard. You get the NFT and that's all it's going to be. But you could imagine maybe a game piece where you're playing a Dungeons and Dragons typed text-based game on the internet, and as you make decisions, those decisions change your character. So if you pick up a sword, your NFT image now has a sword in it based on the one you picked, and then it's there. So when you have a dynamic NFT, you have a more one-to-one relationship with what you'd expect to happen, and you have a lot more opportunity as a creator on what you'd like the experience to be in, again, a more immersive environment where your game pieces evolve over time and your decisions are there. So even when you sell it on a secondary market, that character now has these equipment pieces instead of in some sort of centralized database. It's on the non-fungible token. I also think that it's really cool for real-world changes. So let's take music, because that's where my mind's at. We're launching some music today on Turtle Moon, D&D, and if you were to go to, say, a D&D live music show, and they had a geofence understanding that you came there and you had their NFT, they could update your metadata to add a secret track or a backstage or behind-the-scenes thing so you can make a more immersive NFT that gives extra content to how you engage with it in real life. There's a lot of different time-based examples, geofence examples that would allow, again, that more immersive experience on what is an NFT and how do you interact with it, and how do you bridge the gap between real life action and then digital updates and accruing of value or accruing of changes. And then I think what's really interesting, especially with Hedera definitely having a focus on enterprise, is the ability for various industries to not have to burn and remint, which is how you'd have to do it if you want to update metadata today, and rather have, say, one NFT for a supply chain or a real estate that can continually be updated, that allows the provenance to be there in the metadata without having to change its unique identifier or anything that's really obtrusive to being able to track it succinctly. Instead, you can just update it, and those updates are recorded on the mainnet. So you can see when it was updated, and you also don't have to change any of your unique identifiers. So same functionality with enhancements. When we've been talking about this, there is there was a community questions about, okay, well, can someone just change all the NFTs that I own? And this is a forward-facing change. So if you've minted a token ID today, there's no way to put a metadata key that will allow you to change that metadata because it wasn't on the token when it was created. So in the future, once this is put into the mainnet, if the metadata key is on the token ID, which Hashpack, Blade, I mean, they show you those keys that are there, so you can see, okay, there's a metadata key on this NFT token ID, they'll be able to change it. So as a consumer, you'll understand that this might be changed over time, and it will only be applicable to new NFTs. So any NFT that you got so far, they're going to be safe, and you can still guarantee that they're going to be stagnant. The real-world impacts, I think, are really high. Again, updating NFT metadata is going to give a greater ability to transact in real-world experiences with digital ownership and value. The creators maintaining on-chain update history is really important to see that you can tell exactly when your NFT was updated, and you can always check the mainnet because of the way that this metadata key works, which is pretty great. And I don't know all of the ways that this is going to be used because it's so fundamentally changing how NFTs can exist in Hedera that I'm just excited to see how developers pioneer this new advanced use case. Dynamic NFT in action, here's an example. You have a real estate NFT of a house. It initially just contains the basic details of that house. Over time, it's updated when it reflects renovations, property value adjustments, new rental agreements, and that provenance is also recorded on chain, and you see the metadata change in the main NFT. So this is just one example of how a real-world use case could use a dynamic NFT for a real-life world asset that would give them more functionality than the functionality we have today without this HIP. And I believe the future is dynamic. We are continually striving towards advanced NFT utility. I know that Hedera's underlying technology is innovative. Just look at Galaxy and how they can make an extremely great user experience while also doing things on Web3. There's not many networks that you can build on top of that can be that seamless. And it's a vibrant ecosystem with ever-evolving token experiences. And I think this is going to be a really nice feather in the cap of what Hedera can be. And again, creation should explode in all directions. And I do have time for questions, but I don't know if I have time for questions.
That was amazing, Patches. The future is dynamic and it looks bright indeed. So thank you so much for that overview. I didn't see any question. Lots of comments regarding how cool dynamic NFTs are and the promise of the compelling use cases that we can see from it. So we'll keep an eye on the chat, and if any of those questions come up later, we can maybe tackle them in the last few minutes after Andrew's overview. So with that, let's move on to the Validation Cloud overview. Andrew, all you.
Perfect. Thank you. So I'm here. My name is Andrew McFarland. I'm the CTO of Validation Cloud, and we are a Web3 infrastructure company with 3 core pillars of the platform: staking, Node API, and data as a service, which we offer enterprise-grade infrastructure and services to many of the top ecosystems in Web3. And we're excited about our Node API launch supporting Mirror Node and JSON RPC Relay for Hedera, and that's why I'm here today talking to the community. So we're officially live on mainnet and testnet with our service. So everyone can go to our platform at validationcloud.io, sign up, and start using the service. What that looks like is from a single API key, you can interact with mirror nodes as well as the JSON RPC relay. In case anyone's not familiar with these services, mirror node service is for access to historical information on chain, really key for performing transaction analytics If you're a professional service firm auditing historical transactions or monitoring events for event-driven workflows. And on the JSON RPC relay side, really brings in EVM compatibility, which is really exciting for the ecosystem. That brings in many key features. A few here, wallet support, so MetaMask which is really interesting for the ecosystem. The ability to interact with DeFi protocols that can be seamlessly ported over to Hedera, and build with more Web3 tooling that supports EVM compatibility. So we're really excited about this launch. A little bit more about our infrastructure. So we tailor it to be enterprise grade, whether you're new to the ecosystem or whether you are a sophisticated enterprise already built on Hedera. You'll find great usage of our platform and the key features. And there's 3 core tenets of the platform: performance, resilience, and compliance. So firstly, we're proud to say that we've ranked number 1 for global performance on compare nodes for the last couple quarters. So the number 1 fastest way, lowest latency, high throughput to connect into Web3. Global resilience. So we run global infrastructure. So no matter where you are, you get tapped into the closest point of entry for you to minimize latency, but that also doubles as a global backbone for high resilience and uptime, so high availability for your application, your company. And then finally, SOC 2 compliance, which is the gold standard for security. And so that's very important for a bunch of data security and regulatory compliance around access into Web3. Our platform is very simple to use. You can go up and sign up very quickly and immediately generate an API key for the infrastructure. All you have to do is go to our Node API service, select Create Endpoint, and you'll be prompted to name your API key, select Hedera, and then either mainnet or testnet, and then you can get started immediately with making calls to both the Mirror node and JSON RPC relay with that single API key that's generated. We have 2 tier options. First, and for those getting started or just want to trial the platform, there's a free tier, which provides up to 50 million compute units. There's no credit card required, and you'll get a fantastic user experience representative of the platform, up to the 50 million compute units for free. The second option is the scale plan, which is a pay-as-you-go model, so unlimited compute units that you can drive through the platform. It has a global delivery network and 0 rate limits on this tier. And so it's fabulous to match any type of scale of your business. You just simply pay for the amount that you use and just get going. What's also interesting on the scale plan is that there's economies of scale. So the more usage that you push through the endpoint on scale plan, you'll pay a reduced cost per compute unit, which is quite exciting for folks as they scale. Finally, as I mentioned, you can sign up now at validationcloud.io or through app.validationcloud.io, which is directly to our platform. And you can follow us for more updates around our launches in the Hedera ecosystem on Twitter at validationcloud is the handle. So thank you, everybody. We're excited to be a part of the Hedera ecosystem and excited to have you all try our mainnet and testnet launch for Mirror node and JSON RPC service. Thank you for your time.
Thank you so much, Andrew. This was super valuable and very exciting. So we're very happy also to have Validation Cloud and your team as part of the Hedera ecosystem, providing this critical infrastructure for growth of the network and adoption and enabling use cases to come over and migrate and experience all the good things that Hedera has to provide for developers and users. So very happy to see this. All right, so we are a few minutes over. We're about 7 minutes past the hour. And so I think at this point, given that others may have hard stops, other commitments, let's take a brief look at the chat and see if there are any questions, and then we'll end the call after maybe taking some of these questions. So it looks like the topic on decentralization efforts, we'll have to move that to a subsequent call at some point in the future. And I do apologize for that, but I think so far we've covered a an amazing amount of ground and really, really good topics in this call. So coming back to the chat, well, we just addressed this. So we'll give it a few more seconds to see if any last minute questions come in. And then we'll give the time back to our presenters. I see a question come in from C. Strickland. Will the new features be added to an instruction manual? I would love some additional context on that. Maybe there's a previous message that I'm missing there. But what I can make reference to is a roadmap that we have available on our website, maybe listing features that are on the team's radar, and also keeping an eye on HIPs, right? Because those are things provided by the community, ideas provided by the community that are also evaluated by the team, as Michael referred to in his segment. Nana, thank you so much for sharing those resources for your talk. I think those are going to be very valuable for everyone in attendance. So I see a question for Leo. So for someone who's completely new to crypto and Hashgraph and has no college degree, what do you recommend one does to learn how to code for Hedera? Leo, I would suggest getting started maybe in the Hedera Learning Center and also the Hedera.com website. We have a great portal where you can get started with some resources. And of course, you may need to ramp up your skills, on JavaScript and other programming languages to, enable you to build applications on the Hedera network. But, you can also learn the coding skills and the theoretical skills with a combination of the Hedera Learning Center, the Hedera Getting Started portal, and the resources there, and maybe external learning to supplement your journey on JavaScript or Java or some of the other supported languages. Perhaps a question for Nana here from Circle. How many or what percentage of EVM equivalents have you achieved already? I know this is a tricky, difficult to answer question, but Nana, any thoughts to add there on where we are on our EVM equivalence journey?
Yeah, that's a very interesting question in terms of percentage. I would say we're well along the way, definitely past 50%. Of course, I'd say for the core functionality, you're able to deploy, interact with contracts using most EVM tools as if you were on any other chain. You can use MetaMask, you can use Hardhat, Truffle, Ethers.js, Web3.js. You can currently spin up a graph node and index. So for the most part, for most users, you're good. But of course, there are always these edge cases around different complex scenarios when it comes to different dApps. And those are the things that we're digging into. So I don't have a number, but I'm really interested in this. So if your scenario does not work, please open a ticket up on the appropriate repo, either the smart contracts or the relay or even the services repo, and the team will see that, and we're digging in. So I'd say community feedback is really helpful here to see what may be missed, because smart contracts let you do everything and anything. So it's really hard to cover 100%, but I definitely say, if I had to put a number, we're definitely over 70%, and we're making progress to get there soon.
Outstanding. Thank you for that, Nana. I see a question from Pluto from the Hashback team. Happy to have you here, Pluto. So for Validation Cloud, so Andrew, this one is coming for you. Could it be set up as a fallback mirror node where when not in use, it has zero cost, then only costs when in use? Most mirror nodes require a plan with fixed limits. Would this be scalable? I lost the train of thought there, but I think the additional is just a comment elaborating. So Andrew, if you feel like that you can answer that question, please go ahead.
Yes, absolutely. And this is a great question, Pluto. So you're correct. The sort of status quo for infrastructure services is to pay for fixed tiers, which you're stuck paying for irrespective of your usage. With us, we've spent a lot of time designing it to be user friendly. So whether you're on free tier, obviously you don't have to pay at all on that tier, and then there's a pay-as-you-go model for the scale plan. So the answer is yes, you're not forced to pay a certain amount. You pay based off of your usage on that plan. Great question.
Excellent. Yep, thank you for confirming, Pluto. All right, so we are almost at 15 minutes. I do think there have been excellent points, excellent questions, and excellent discussion here, but I do want to be mindful and respectful of everyone's time, and perhaps people in the speaker panel may have other commitments to get to, and same with our audience. So I want to thank you all again once more for joining us. A big thank you for the speakers for all the preparation and the work that went into this. And we look forward to sharing more and hearing more from you in the next community calls. But again, you don't have to wait till the next community calls. So feel free to give us your feedback via the survey, via social media, via GitHub, and we'll be happy to take your thoughts into consideration for driving improvements. So once again, thank you all, and I hope you have a great rest of your day.